Hello everyone, and welcome and thank you for joining ERA's webinar titled Creating a Robust and Sustainable Quality Assurance Program. My name is Rick Persicchiti. I'm an account representative here at ERA, and I'm joined with Tom Wadera. But before I turn it over to Tom, I have just a few details for you. First, this webinar is being recorded, and the recording and a copy of the slides will be posted on the ERA website by the end of tomorrow. Second, all attendees are currently in listen mode, so if you do have a question during the presentation, please type your questions in the question box. Then at the end of the program, as time allows, we'll answer questions that come in during the webinar. So, a little information about ERA. For those of you that are not familiar with ERA, plain and simple, we manufacture reference standards. We do it 5 days a week, 52 weeks a year. Standards have been our business for more than 36 years. ERA is headquartered in Golden, Colorado, about 10 miles west of Denver at the foothills of the Rocky Mountains. For those of you not aware, our new 66,000 square foot facility here in Golden includes more than 25,000 square feet dedicated to laboratory space. ERA was acquired by the Waters Corporation in 2006. Waters Corporation is a manufacturer of liquid chromatography and mass spectrometry instruments, among other things, which is why the photo on the screen you see the Waters name above the front entrance. If you find yourself in Colorado to do some skiing or hiking, we invite you to come by and visit us here in Golden, as we'll be more than happy to give you a tour. So ERA is the leading provider of proficiency testing products, certified reference materials, and reference standards. Our products are used by more than 7,000 environmental laboratories in more than 80 countries. We have more than 35 scientists on staff, and our customer service, sales, and support teams include individuals with advanced degrees in chemistry, environmental science, and biology. Every year, ERA offers 52 proficiency testing studies in a variety of matrices. Our annual PT study schedule includes monthly studies for wastewater and drinking water, and then quarterly studies for soil, air and emissions, and radiochemistry. We also have prepared more than 1,000 custom standard projects each year. ERA is a TNI accredited proficiency testing provider. We are also certified as a reference material producer and a chemical testing laboratory by A2LA. We are also registered to the ISO 9001 standard by the National Quality Assurance Organization. In addition to serving the environmental segment, we also manufacture reference materials and calibration standards for total organic carbon, conductivity, turbidity, and pH for the pharmaceutical, medical device, and biotech manufacturers. In today's presentation, Tom will talk about the 4 functions of a laboratory's quality assurance program. Because the use of certified reference material is an essential part of a robust and sustainable program, I want to begin briefly with the definitions of reference material and certified reference material. ISO Guide 34, 2009 defines reference material in section 3.4 as material sufficiently homogeneous and stable with respect to one or more specified properties, which has been established to be fit for its intended use in a measurement process. So that's a reference material, homogeneous and stable, fit for its intended use. So what makes reference material a certified reference material? Well, the definition of a CRM according to the ISO Guide 34, Section 3.5 is reference material characterized by a metrologically valid procedure for one or more specified properties accompanied by a certificate that provides the value of the specified property, its associated uncertainty, and a statement of metrological traceability. In other words, a certified reference material is a standard with known concentrations or assigned values of specified analytes. The standard has a known uncertainty and is tested for homogeneity and stability. The assigned values are traceable to an independent reference, and the CRM is accompanied by a certificate of analysis. The certificate of analysis, you can see a sample on your screen, includes references to the characteristics of the certified reference materials, including the certified value, the uncertainty, the performance acceptance limits, the NIST traceability, among other details. Okay, it's now time to turn the presentation over to Tom Wadera. Tom is ERA's Inorganics Product Line Manager. He is a graduate of State University of New York, Potsdam, with a degree in chemistry. Tom has worked as a chemist for more than 24 years and has now been with ERA for more than 12 years. Tom will give you specific information on 4 laboratory functions and how they impact your quality assurance program. So go ahead, Tom, take it away from here.
Thanks a lot, Rick. All right, let's get started. So good morning or good afternoon, everyone, as the case may be. I know you all have busy schedules, so thank you for taking time out of those busy schedules to learn more about the essentials of a robust and sustainable quality assurance program and how your quality assurance program can be enhanced with the use of certified reference materials. To begin, as Rick had mentioned, there are 4 basic laboratory functions to a robust and sustainable quality assurance program. And those 4 are method development, staff training, ongoing performance, and corrective action. So the first area I'm going to discuss today is the method development. Before performing your method development, it's important to determine, if possible, the type of samples that will be analyzed and the expected concentrations of those samples. Knowing this information will allow you to develop your method to meet your specific sample needs. When a new method is being developed, it's important to determine if the method meets the defined method criteria, including precision, accuracy, analysis range, and ruggedness. For the purposes of our discussion today, I'm going to limit the topics to precision and accuracy when talking about our method development. So what's more important when developing a new method? Is it precision? Is it accuracy? Well, I would say that they're both equally important. So let's take some time to compare and contrast these 2 areas. By definition, precision is the degree of agreement between independent measurements under controlled conditions. Let's think of that about as far as how well a method can repeat a given number. Precision is statistically represented by a standard deviation. In contrast to that, accuracy, by definition, is the degree of agreement of a measured value with the true or expected value. In other words, how close those measurements are to the true value. Accuracy is statistically represented by the percent recovery. So you're looking now at a graphic which is showing precision and accuracy and the difference between the 2. The picture on the left shows results that are precise but not accurate, as depicted by the results that are very close to each other but not very close to the true value. Whereas the picture on the right is showing results that are accurate but not precise. As you can see, the results are fairly close to the true value, but they're not really that close to each other. So precision can be determined by 2 methods. There are short-term studies and there are long-term studies. Both of these studies will determine variability in the method, but in slightly different ways. Our short-term variability, or repeatability, can be accomplished by running a standard of known concentrations several times, usually at least 7 different replicates. These replicates are run in a short period, generally 1 to 3 days. This will allow you to determine the precision under the same preparation and same analysis conditions. Long-term variability, or reproducibility, on the other hand, can be accomplished by running a standard of known concentrations over an extended period of time. This could be weeks or even months. This will allow you to determine what we call ongoing precision, which is under potentially different instruments and/or laboratory conditions. When trying to determine the accuracy of your method, you want to try to eliminate as many variables as possible. One of those variables is the potential for human error from manufacturing your own accuracy standard. This variable can be eliminated from your method development with the use of a CRM, because the value of the CRM has already been validated by an outside independent source. Therefore, if your method criteria is not met, during that accuracy analysis, you'll know that that's a result of a deficiency in the method and not an issue with the standard itself. The acceptance criteria for the accuracy of your method can be determined either from the method-based criteria, or the criteria that is written in the method, or by your own in-house QA/QC criteria. That latter involves the use of control charting, which I'll explain detail in just a few moments. So now I want to go on to the second component of a robust or sustainable quality assurance program, which is staff training. So once your method development is completed, the staff who are going to run the method need to be trained on the execution of that method. Staff training, I'd say, is a quintessential part of an effective quality control program. First, initial hands-on training needs to be conducted by experienced laboratory personnel. And I want to repeat that because it's very important that that training be conducted by experienced laboratory personnel. That will ensure that the staff understand and will effectively execute the method. The training will ensure that analysts not only understand, but will follow the procedures. So after your initial hands-on training, I would highly suggest that the trainer spend time observing the trained analyst to ensure both compliance to the procedure as well as the analyst understanding lab safety rules and the importance of ethics in running and reporting your lab samples. So sometimes in providing verbal training, what one person says and what another person hears can be vastly different. I experience this all the time at home with my teenagers, and I would suspect that those of you with children at home know what I'm talking about. Therefore, it's important to ensure that the training was effective. CRMs are an effective tool as hands-on training tools to demonstrate what we call the capability of a trained analyst. The results of the CRM analyses from that analyst can be used to document not only the initial but also the ongoing precision and accuracy. And that brings us to now the third laboratory function that's critical for a robust and effective quality assurance program, and that's involving ongoing performance. So once your staff are trained and they've demonstrated that capability, then effective quality assurance must involve monitoring the ongoing performance. CRMs can be used to monitor the variables that may affect an established method. And these variables include analysts, instruments, and laboratory environment. So although written procedures are present for your method, generally more than one person will be running that method. Variations in analysts' laboratory techniques can affect both precision and accuracy of the method. Analysis of a CRM can help ensure that any variations in analyst techniques will still result in data that meets method criteria. Our second variable can be the instruments themselves. Let me make an analogy for you. For those of you who drive cars, you know that as time goes on, the performance of your car will change. Well, the same holds true for your instruments. So CRMs can help you monitor the continued acceptable operation of your instrument as its performance can change over time. A third variable is the laboratory environment itself. Most analytical equipment is susceptible to changes in temperature and humidity in the laboratory. So for those of you that live in very hot and humid climates, you'll understand this in the summertime when the temperature can reach 90 degrees and 95% humidity outside. What happens during the day is the temperature and the humidity will change drastically in your laboratory. So the continued use of CRMs can help you catch instrument drift that might result from the changes in your laboratory environment. So how exactly does a routine analysis of CRMs help you to ensure optimal performance? Well, CRMs can be used as calibration materials for your instruments. One benefit of using ERA CRMs for calibration is that they come from a trusted source and are traceable to a NIST Standard Reference Material, or SRM. The same source that you're going to use to calibrate your instrument can also be used as what we call a continuing calibration verification, or a CCV standard. These standards are analyzed at routine intervals during the analysis, which can be either a certain number of samples or at a predetermined time interval. This will allow you to check for analytical drift. And the reason for this is that if your CCV is made from the same source as your calibration materials, then the only thing you're checking is to make sure that the instrument hasn't drifted since you're using the same source. CRMs can also be used as an independent calibration verification, or what we call an ICV. As a source independent of the calibration source, the ICV is used to ensure that the calibration standards were properly prepared. The ICV is generally prepared at a mid-range of the calibration, and the results of those ICVs will then be used for your control charting process. So the benefit here, and where this helps us, is that it helps us to determine if the calibration was done properly. Since the ICV is made from a source different than that calibration, if the calibration was made properly, the ICV will recover acceptably. If the calibration wasn't made properly, then the ICV will reflect that and will not recover within your method specified criteria. So now I want to go into talking into depth about what we call control charting, as control charting is a critical part of your quality assurance program. Too often I hear stories from our customers that are caught off guard or surprised when a CRM is not meeting the documented acceptance limits. Quite frequently, and unfortunately almost too frequently, I learn that these same customers are not utilizing a control charting process, because if they had, they would have been alerted when their method began trending unfavorably. So what is control charting? Well, control charting is the process of plotting the percent recovery of a CRM each time the CRM is analyzed. Ideally, the CRM is analyzed with each analytical batch, or at least once a day that the analysis is performed. I highly recommend using the same CRM provider for your control charting samples. This ensures that any potential variations between your CRM manufacturers won't be affecting the recoveries of your control charts. If you consistently use CRMs from the same accredited provider, you will not experience lot-to-lot variations. So let's talk more about control charting. As you see in front of you, there is an example of an analyte control chart. So let me explain the components of this control chart. Recovery of your CRM is plotted over a period of time and control limits are established. So if we take a look at the control chart that we're looking at, you see some data and a bunch of lines. So what you see here from a statistical standpoint are warning limits and control limits. So statistically, a warning limits are plus or minus 2 standard deviations. And that's depicted on our chart by the green line, which we see LWL, which is lower warning limit, and UWL, which is the upper warning limit. Statistically speaking, our control limits are 3 standard deviations, and those are depicted on the chart in red by LCL, which is your lower control limit, and UCL, which is your upper control limit. So after 20 data points are plotted, your control chart warning and control limits are going to change. They may become tighter or they may become wider depending on the consistency of your ICV analysis. Now it's expected that you're going to have equal numbers of data points both above and below the 100% recovery line. As long as your data points are within the warning limits, your method is well within control. If your data points are between the warning limits and the control limits, your method is still in control. However, you're approaching a situation where the method is bordering being out of control. And once your data points fall outside of the control limits, your method is now out of control and corrective action is necessary. So if we take a look at our data points, this is a typical control chart for data points. The data points that you're looking at here are depicted in blue. So we look at data points, you see some of them below the 100% line, you see some of them above the 100% line, and we see that our data tends to go up and down and up and down. We have a few data points that go up consistently, a few data points that go down consistently. So if we look about halfway through, we see 4 data points that are all going downwards one after another. That's what we call a trend. We see our data trending downwards. And it trends downwards to a point where we have one of those which is outside of the control limits. Once that data point is outside of the control limits, the analysis needs to be stopped and a corrective action needs to be done. One of the things that this trending will help us with is that once we take a look at that data and we start seeing a trend going one way or going the other way, we can then start doing what we call preventative action. So that's a great value in control charting, is the preventative action. And we can do that to prevent our method from trending out of control. If our data does trend out of control, we need to stop that analysis, implement a corrective action, and then document that the corrective action was successful before we can resume our analysis. So that leads us to the corrective action, which is the final piece of our effective quality assurance program. Now I'm going to be honest, despite all attempts at keeping your method in control, there's going to be times when changes in your method conditions will cause it to go out of control. And there are several indicators for this. One indicator that our method is out of control is the failure of a proficiency test. So if we hand in our blind PT results and our report comes back and it says that the data is not acceptable, that's letting us know that somewhere, somehow, our method is out of control. A second indicator would be a calibration that doesn't meet your method-specified criteria. And a third indicator that our method is out of control is when the control chart that we had just looked at shows that our analysis has drifted outside of the control limits. So we're at a point now that we've established that a corrective action is necessary. So how do we go about performing that corrective action? Well, the first step we want to do is to perform a root cause analysis. Now, a root cause analysis is absolutely critical in making sure that we find out the correct problem that has occurred and that we perform the correct corrective action for this. So the root cause analysis is going to help us to determine the cause of our problem. And once it's been identified, corrections need to be implemented, and finally, we need to confirm that the corrections are both appropriate and effective. So I want to take some time now to discuss the details of a root cause analysis. With any method failure, there can be 4 causal factors: man, machine, material, and method. So let's talk about the first one, man. Okay? What we want to do is we want to look at, has there been a change in the analysts or the individuals that are actually running that method? Is the analyst that's running the method is there retraining necessary of that analyst? So those are the things you want to kind of look at when we look at, is it man that's causing our problems? We also want to look at the machine, the instrument itself. Have the conditions of that instrument changed significantly over time? An example of that would be you're running your ICP-MS and you take a look at the parts of the ICP-MS and you notice that your cones have become extremely tarnished. That can result in analyte sticking to the cones, improper spray into the chamber. And so we look at that, and that's one way of determining, hey, maybe it's our machine or our instrument that is causing the problem. So the third area that we want to look at when performing a root cause analysis is the material. Is the calibration or the CRM standard that we're using, is it outdated? Or are fresh dilutions maybe needed of those standards? And what happens maybe if you're using an older stock solution or an older dilution of that is the standard might become concentrated on you, which will cause low results. Maybe an analyte has fallen out of solution. So those are the things you want to look at when looking at the materials that you're using in your analysis. And finally, you want to look at the method itself. Has something changed in your method causing a failure? Has the criteria changed? Or has it changed in such a manner that would require additional method development? So you want to look through each four of these potential causal factors to try to see which one or ones maybe have caused the method to become out of control. Once your root cause has been identified, the source of that cause needs to be addressed and the corrective action needs to be implemented. Once implemented, it is then necessary to confirm that the corrective action is both appropriate and effective. This can be accomplished by analyzing CRMs because they're accompanied by a certificate of analysis that details not only the certified value, but also what we here at ERA call performance acceptance limits, or PALs. Once the method is established to be back in control, the control of that method can be sustained through reestablishing the long-term control charting. So I want to reiterate that the quality assurance program is dependent on four laboratory functions: your method development, your staff training, your ongoing performance, and your corrective action. If you really want to make sure that you've got a robust quality assurance program, it's critical that each component here, each function, be properly designed. And to sustain your program, ongoing evaluation of that program is equally critical. It's an evolving and it's an enduring process. So that ends our discussion on the four basics of quality assurance. So before I turn the presentation back over to Rick, I'd like to quickly wrap up my presentation with a brief review on CRMs and the value that they provide in your quality assurance program. ERA offers a line of certified reference materials, or CRMs, for a variety of applications, such as organic chemistry, inorganic chemistry, radiochemistry, and microbiology. We also offer them in a wide variety of matrices, including wastewater, drinking water, soil, municipal sludge, and air and emissions. If so desired, ERA can also provide custom CRMs for certain special projects, such as ready-to-use calibration standards. If you have a special need, you can contact an ERA representative to learn more about our custom standard program. One of the advantages of ERA CRMs is that most have previously been through one of our proficiency testing or PT studies, which means that data from the PT study provides additional support for the assigned values and the acceptance limits of the CRM. Our CRMs contain known concentrations of various analytes. The standards are supplied with a certificate of analysis that details the certified value, the uncertainty, the acceptance limits, and the performance of that standard with its associated PT study. ERA CRMs are all manufactured in our ISO Guide 34 accredited manufacturing facility, and that all the standards are analytically verified by ERA in our ISO Guide 17025 accredited laboratory. The values for each analyte are assigned based on what we call weights and measures. What that means is that ERA certifies each analyte by how much of that analyte is spiked into the CRM. Our CRMs are manufactured using only NIST traceable balances and calibrated Class A glassware. Where available, ERA CRMs are traceable to a NIST standard reference material, or SRM. Finally, we have multiple lots in stock at any time. That will help provide flexibility for you in choosing certain analyte concentrations. And again, there are a wide variety of uses for our CRMs. You can use them as a routine quality control of your entire process. For method development, most specifically the accuracy of your method. For control charting of your ICV. For demonstrating capability of a trained analyst. For confirming the appropriateness and effectiveness of corrective actions, and for calibrating your instruments with each analytical batch or each day that the instruments are used. I cannot say enough about the value of CRMs and the role that they play in building your robust and sustainable quality assurance program. But enough with the selling from me. I believe that we've received multiple questions, so I'm going to turn it back over to Rick so that he can field the questions and we can do what we can to answer them. Rick?
Well, thanks, Tom. That's some great information about CRMs. I believe I learned something about the value of using CRMs in a laboratory's quality assurance program as well. So, yeah, we have been taking in some questions here, and we've got a little bit of time to address those. So let's pull out the first question and see what we have here. All right. On my control chart, if I get a data point that falls outside of the warning limits but is within the control limits, what should I do? Tom, would you like to address that question?
Yeah, I sure would, Rick, and thanks a lot for that question. So what that data point is representing is a method that is still in control but is approaching the border of those control limits. At this point, I would highly recommend employing what we call the preventative action measures to help bring your data back within the warning limits. What's good about this is that the preventative action will look at the same areas that corrective action measures do, but it allows you to continue running samples while you're investigating because your data technically is still in control. Doing preventative action in most instances will prevent your method from going out of control because at that point you're going to need to stop your sample analysis and do an actual corrective action.
Well, great, Tom. Thank you very much for that answer. We do have a second question here, and it's asking that, Tom, you mentioned that CRMs will help me with the accuracy portion of my method development. Why would the CRMs, be more helpful than making my own standards within my laboratory?
Hey, that's a great question. When you're doing method development, you want to try to eliminate as many variables as possible, one of which is the assigned value of the standard being tested for accuracy. And I'm sure that you're experienced in manufacturing your own standards. But if the accuracy of the analysis doesn't meet your method-specified criteria, by making your own standards, you might not be sure if the failure is due to a deficiency in the method or to an improperly made standard. A CRM can eliminate that variability because it is a standard that has been independently certified. So if there is an issue with the method criteria, with the recovery in that method criteria, you know that the deficiency is due to something going on in the method, and not the standard, because it's independently certified, you know that the value is accurate.
All right, I think we've got one more question for you, Tom, that we have time for. And this comes in, it's asking whether or not you, let's see what it says here, the reference material, do you have a reference that refers to the frequency of the ICV or check standards? You mentioned earlier in your discussion that there were different intervals for those. Do you have a reference for this person to find out what that frequency should be?
Well, thanks again for that question. That's going to depend on your specific situation. There isn't necessarily a single reference document that says this is how often we should do things. There are a couple of factors that can affect that. It could be that your in-house QA/QC program, any of your quality management system documents, might say that specifically. So you want to check with your quality assurance department in your laboratory to determine if they have decided, hey, we want to do this once a day, we want to run them every 10 samples, we want to run them every certain number of hours. The method itself could also depict that. For those of you who work in the contract laboratory program for the EPA, the CLP statements of work specify exactly how often you need to run an ICV or you need to run a CCV. And generally, it's like, say, for inorganics, probably every 10 to 20 samples at the beginning of the run and at the end of the analytical run. Say if you're looking at doing organics, organics are generally time-bound, which maybe you need to run those once every 12 hours or so. So again, there isn't really a specific document that tells us that, but it could be a variation of documents. You could be working on a special project for an engineering firm or something, and the quality assurance project plan for that project might state that specifically as well. So there, again, there can be a variety of places that you can find that.
Another very useful answer there, Tom. Thank you very much. That's some very good information today. Unfortunately, we're going to have to wrap it up. We're out of time. And I want to thank everybody for joining us today. You will be receiving a webinar evaluation this afternoon, and we will ask that you give feedback on today's presentation as well as suggest topics for future webinars. The topic, date and time of our next webinar will be announced in our August newsletter. So look for the ERA newsletter from Miss Anna Light, yes, that's Anna Light, to land in your inbox early next month. And if you're not on our newsletter email list, be sure to sign up and send an email to info, I-N-F-O, at eraqc.com. Keep that email handy for any questions you might have or any communication you want with ERA. Info at eraqc.com. You can see that on the slide right now. So thank you again, and this concludes our presentation. Until next time.